So a quadric surface is the zero set of a polynomial in 3 variables. Okay, and it's a polynomial of only degree 2. So if you look at this one, this horrible thing that I've written in front of us here, each term only has degree 2 or less. So there's 2 copies of the same variable or different variables, or just one, or none at all, right? So it's a polynomial of degree 2 in 3 variables. Okay, and so then a quadric surface is just a zero set of such a polynomial. So the set of all points in R3 where that polynomial is equal to 0. So we just saw examples of this. For instance, those cylinders that I just showed you, the circular cylinder was the case when A was equal to 1 and B was equal to 1 and J was equal to -4. And then that equation becomes x squared plus y squared minus 4 equals 0. And we saw how that graphed out as a vertical cylinder like this, right? Okay, so the bad news is that this formula is horrendously complicated. The good news is that we don't need most of it. So for any example, if we have, like I told you that we would not be considering things like cylinders that are oriented in wonky directions, non-parallel, well, it's too wonky to survive, that are not parallel to the axes and everything. That corresponds to these terms right here. So we're just going to throw all those terms out, because just by reorienting the cylinder, we can always, or reorienting our axes, we can always make it so that the cylinders are parallel to our axes. And I'm saying cylinder, there's other kinds of quadric surfaces. We'll get to those in a moment, but they can also be oriented along an axis, and we'll see how that goes. So then it's a matter of what the how the signs are oriented in term or arranged in so that to determine what the surface is. So these the linear terms x, y, and z, those will correspond to offsets, like whether or not something is centered around the axis or kind of running parallel to it along the side, or it will set up a relationship with one of the other variables that we're given. So here are the possibilities that we will have to contend with. Let's see. So if we have only one squared term, okay, like that second example that I graphed for you, it had neither of these terms and it had neither of these terms, right? And we got a parabolic cylinder, and that is going to be a general thing. So we get a parabolic cylinder. If we have two squared terms and no linear, so a linear term is x or y or z. So if none of those appear, then this is like the second example that we saw, and we get a circular cylinder, or more generally an elliptical cylinder. That happens if A and B are different, for example. And then if A and B have opposite signs, then you might also get a hyperbolic cylinder. So that looks like a hyperbola that's been dragged out in space to make a bizarre X-shaped double rain gutter type thingy. And then if we have all three, so if we have two squared terms and one linear term, then we'll write it in sort of the standard form. And if we have if the squared terms are same sign, so both positive or both negative, then that's going to give us an elliptic, what's called an elliptic paraboloid. And we'll look at an example in just a moment. And if we have that these squared terms have a different sign, then we're going to get what's called a hyperbolic paraboloid. And then we have the cases for when we have all three squared terms appearing. And there's a bunch of different possibilities for that. That can give us ellipsoids, and it can give us hyperboloids. And so we'll see how that works. So the general or standard form that we will always look at for our quadratic surfaces is going to be, we will take if all squared terms have the same sign, we will write them to be positive. So for example, if you had minus 3x squared plus y squared minus 2z squared equals 1, then the standard form for that, I would say, oh, let's look here. I've got 2 negatives and 1 positive. So the standard form would be to make the 2 of the like sign both positive. So I would multiply this through by minus 1. And that would give me 3x squared minus y squared plus 2z squared equals minus 1. That'll help me figure out which type of surface it is much more easily. So if one term has a different sign, multiply by minus 1 to make it negative. And that will help us classify them. Okay, so I just gave you all these crazy terms, paraboloids and hyperboloids and ellipsoids and whatever. Now let's go explore those and find out what those are in the next clip.